Welcome back. Visca the teacher here, and we are going to continue our journey on the Algebra 2 Regents examination for June of 2022. In this video, we are going to do problems 9 through 16. In the previous video, we already did numbers 1 through 8, so we will continue right at 9 straight through to 16. Number 9. Okay, monthly mortgage payments can be found using the formula below. That is a very complicated formula, where M is the monthly payment, P is the amount borrowed, R is the annual interest rate, and N is the total number of monthly payments. Now, I don't know about you, but I know a lot of students that would see that equation and say, geez, maybe we didn't use that exact equation, and you buckle. That looks complicated. They give up before they are even fully into the problem. Let's read the question, and I'm going to show you, how simple this actually is. Okay, so if Adam takes, out a 15-year mortgage, borrowing $240,000 at an annual interest rate of 4.5%, his monthly payment will be. So first of all, let's establish what we're trying to solve for. Monthly payment. That's M. Okay, we're trying to solve for M here. If I need to solve for M, that means I need to have everything else on this side has to be given to me. So really, they are going to give me a value for P, a value for R, and a value for N. All I need to do is put it in the calculator and hit enter. This problem is really testing you to see if you can use the calculator when you have fractions within fractions. It's really, really simple. So let's start, shall we? Blue. First thing is 15-year mortgage. Okay, that's going to go for my number of payments. That's going to be my N. However, be careful, please. N does not equal 15. N is the number of payments. Your payments are monthly. You pay them once a month. So how many months are in 15 years? Okay, if there are 12 months a year, times, we have our 15 years, okay, that's going to end up being 180 payments he's going to make. That's 180 months. That's my N value. That's going to go here for this exponent and here for this exponent. So we got the N down. Super. Not difficult yet. Borrowing $240,000. Okay, P is the amount borrowed. So my P is right there. Okay, that's 240,000. 1, 2, 3. Let's put a comma there so it's nice. That's a 0, not a 6. There we go. So that's my P. The last thing I need is the R, and that happens in 3 locations. Okay, purple. Here, here, and here. Okay, so my R, you might say, is 4.5%, but please be careful. Your calculator does not have a percent button. What does that mean? That means we're going to have to slide the decimal over to get rid of the percent sign. 1, 2 times. So there's a lead empty space. We're going to put a 0 there. Then our 4 and 5. This is the value that goes in for R. I have everything I need for this side right here. I have everything I need. I'm just going to put it in the calculator and hit enter. Okay? And at this point, it is really good to have a calculator. All right, the first thing I'm going to do is hit alpha, the green button, and y equals, and then enter. That creates a fraction for me. My p-value, we said that p-value is 240,000, so that's what I'm going to start with, 240,000. Okay, now I have a parenthesis. I'm going to type it in exactly like this. I have another fraction. So I will do alpha y equals, enter again. My r is in the top here. That's 0.045. Remember, I cannot put 4.5%. There is no percent in the calculator. Okay. Below that is just the number 12. I'm going to pop out and close that parenthesis. Have another parenthesis, 1 plus another fraction, alpha y equals. Again, I have my r. Okay, that's this part right here. 0.045 over 12. Pop out of that parenthesis, except here, on the outside of the parenthesis, I have an exponent, which is my n value. That was 180 payments or months over the 15 years. Now I got to type in the bottom, exactly as it is here. Parenthesis, 1 plus, going to create a fraction. In the top of that fraction is my rate, 0.045 over 12. Going to pop out of the fraction, put an end parenthesis, an exponent of n, which is 180, pop off the exponent, and minus 1. You can see how this question, using the calculator, is the toughest part. Actually typing everything correctly. If you didn't use the fraction function, if you didn't create this fraction, you would have had to do a ton of parentheses followed by the divide sign and then another ton of parentheses. Anytime I have a fraction in a calculation, I always use the fraction function. For me, it's alpha y equals. Okay. Enter. There it is. Pull this out here. Boop. There you go. So, $1,835.98. That, to me, looks like choice 3. That's my answer. Right there. Whew. It's a lot to do, especially when you're explaining it. But you can pause, rewind, and rewatch it if you need. Very simple. You didn't have to do calculations to solve for a P or for an R. That would have been a nightmare. We just plug and chug. Whew, man, I'm sweating after that last problem. All right, let's now do an easier problem. Okay, for all real values of x, if f of x is x minus 3 squared and g of x is x plus 3 squared, what is f of x minus g of x? All right, all I'm going to do is I'm going to take f of x and subtract g of x. That's it. All right, so I have x minus 3 squared minus, yep, hit the black again, boop, minus x plus 3 squared. All right, now here's the thing you got to keep in mind. You want to figure out what this whole thing is first, then figure out what this whole thing is on the right is first, then subtract them. Because that minus sign in front of the blue writing, in front of the x plus 3 squared, is going to have to distribute to every term. I'm subtracting that whole thing, not just the first term. Let me explain. First, let me expand this. If you FOIL or use the box method, you should end up with x squared minus 6x plus 9. Okay? Minus. Now, when I say I've got to subtract everything in blue, this is what I mean. If I expand this out, like if I FOIL it, or if I do the box method, when I say FOIL it, if I take x plus 3 times x plus 3, and I do this, I get x squared. I do this, I get 3x. I get another 3x. I get 9. If I actually multiply it out, I get x squared plus 6x plus 9. Now, I said I'm going to subtract everything. If I just leave it the way it is, the only thing I'm subtracting is the x squared. Okay, but I've got to subtract everything, which means that minus sign is going to flip the signs of everything after it. This x squared will turn to a negative, but this positive 6x should turn to a negative 6x, and this positive 9 should turn to a negative 9. Okay, so let me rewrite the problem after I do that distributing. I have x squared minus 6x plus 9. This will become a minus x squared when I distribute the negative to it. This will become minus 6x. This will become minus 9. Now I can combine like terms, and it becomes really easy. How come? Oh, I see a positive 9 and a negative 9. Cancel. Negative x squared and positive x squared. The only thing remaining is a minus 6x and another minus 6x, which gives us a minus 12x. Oh, the things that we know. Nice. Nice. Number 11. If f of t equals 50 times 0.5 raised to t over 5715. Yes, that is 5,715. There's no decimal in that denominator in the exponent. Okay, if that represents a mass in grams of carbon-14 remaining after t years, which statements must be true? All right. Well, either the mass of the carbon-14 is decreasing by half each year, or the mass of the original sample is 50 grams, or it's both of those, or it's none of those. All right, well, look at, I know this value right here represents my initial value, the starting sample. The original sample is 50 grams. That is true. I like that. But let's take a look at choice one. Choice one, half each year. A lot of people will look at this and say, oh yeah, it is going down by a half. No, 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 no. Okay. If I want to know the rate of change per year, okay, t is years. That means my exponent, okay, whatever's here, my exponent just needs to be the t. Okay, I have my 50 out front. So this is what I do. I still have my 0.5 here. I rip my fraction apart, meaning I'm going to say t over 5715, which is my exponent. That's the same thing as saying t times 1 over 5715, right? Like if I multiply them together, 1 times t would give me my t. There's just the 50. I mean, it's the same. So I'm going to do that to the exponent here. Sorry for my writing. 1 over 5715. Now, I actually need to take this part of the exponent and apply it to the 0.5. Now, what's left, I'll have 50. I'll have something in parentheses. Now I just have a t out here. Whatever this simplifies to be is going to be the rate of decrease. Okay? Well, actually, it's 1 minus the rate of decrease. Time to use the handy-dandy calculator. I'm going to turn this on. I'm going to take parenthesis 0.5. Okay, and all I'm going to do is this right here. And I'm going to raise that to 1. You know what? I always said I use the fraction function. So I'm going to do that instead of type it out. Let's say alpha y equals enter. We should get in that habit. I was going to say 1 divided by 5715. It would have been the same thing, but let's get into good habits here. And I hit enter. This simplifies. I'll go 4 digits. Okay, it's 0.999, and this 8 right here will round up to a 9. So, in here is 0.9999. That is definitely not 50% anymore, is it? Okay, technically, that's 1 minus my rate. So if I take 1 minus my rate equals 0.9999, okay, and I solve for r is going to end up like being 0.0001, okay? That's not 50% decrease. 2 is the only answer that's correct. Number 12 has a lot going on, but you know what? It's really an Algebra 1 problem. Thank you for giving me this, okay? Consider the graph of G, which is the graph on the left, and the table on the right of T, which is T of X, okay? Over the interval from 2 to 4, okay? So here's 2 on the X, and here's 4 on the X. Here's 2 on the X for my T of X, and here's 4. Okay. Which statement regarding the average rate of change for G is true? If you don't understand that rate of change or average rate of change really is just a fancy way of saying slope, you better write that down and know it. Okay. Slope, it's rise over run. It's change in y over change in x. So what does that mean? All right. Let's look at G of X, our graph. From 2 to 4, these are X values. So X is 2 right at this coordinate. Okay. And X is 4 right at this coordinate. So let's figure out, in fact, let's do this. Boop, here and here. Those are bigger, easier to see. All right. So let's figure out the y value. So 1, 2, 3, 4, 5, 6. I mean, I could do this 6. So that's the 0.26. 7, 8, 9, 10. That would be 10. I could do it that way. Okay, I have 2 coordinates, and I could do change in y over change in x. Or it's rise over run. I go up 1, 4. That's my rise. And I go over 2. That's my run. My slope for G of X is 2 from 2 to 4, from this interval, from 2 to 4. Okay? That's 2. So now I got to do the same thing for T of X, except I don't have a graph. I don't even have an equation that I could put into a graph. But I do have 2 sets of coordinates, okay? Okay, let's even do this. It's better. The highlighter just, to me, jumps out so much. This is one coordinate, my x and y, and this is my other coordinate. So let's call, let's call this x1 and y1. This will be x2 and y2. So now we're just going to do y2 minus y1 over x2 minus x1. Okay, let's plug in my y2 minus my y1. My y2 is 3. My y1 is -5. All over my x2 minus my x1. x2 is 4. x1 is 2. I'm going to get, okay, 3 minus a negative. When I subtract a negative, it turns into a plus. So that's 8. 4 minus 2 is 2. This is a slope of 4. This slope is larger. That has a larger average rate of change, or a larger slope. T of X has a larger slope than G of X. So G, option 1, has a greater rate of change or slope. No. The average rate of change are equal. No. 2 does not equal 4. The average rate of change for G is twice the average rate of change for T. No, it's the other way around. It's half. It's not twice. So the average rate of change of G is half. There you go. 2 for G is half of 4 for my T. There you go. It's nice to get an Algebra 1 problem. Number 13. This is so simple if you remember one thing. Let's read the problem. Let me move this up out of the way here. It's not really in the way. I just like to maximize my space. All right, so a parabola has a directrix, okay, a directrix at y equals 3, has a vertex at 2, 1, and they want you to, which ordered pair? So you need to find a point of the focus. There is one thing that always holds true when it comes to directrix, vertex, and focus. The vertex is always, not sometimes, not most of the time, not rarely, but always exactly in the middle. I'm going to abbreviate some of these. Middle of the directrix and focus. Oh, I was going to do this for an and symbol, the directrix and focus. If you know this, this problem becomes counting. What do I mean? All right, let's do a little fake little graph here. And by fake, I mean, you know, you're going to do a real little grid here. Sorry, wiggly hands. Now, what this is telling me over here is if my directrix is up here and my focus is down here, the vertex is always in the middle. What if the focus is up here and the directrix is down here? The vertex is always the same distance. It's always in the middle. Okay? So right now, my directrix, oh my goodness, no, let's undo that. My directrix is at 3, y equals 3. Here's 3, here's 2, here's 1, 1, 2, 3. My directrix is a line, goes like this. That's my directrix. Y equals 3. My vertex is at the point 2, 1. 1, 2, 1. So that's the coordinate right here. This is my vertex. That's at the coordinate 2, 1. Okay? The vertex is right in between. So if I have to, okay, if I have to go up 2 to get to the directrix, I have to go down 2 this is 0, that counts the step. I'd go down to 1, 2, and there is the focus. Okay, again, I go up 2, I go down 2. It's always in between, and that is the x value 2, the y value -1. If you just know this, you can solve that anytime. Number 14. The heights of 3,300 students at Ocean View High School are approximately normally distributed with a mean of 65.5 inches and a standard deviation of 2.9 inches. The number of students at Ocean View who are between 64 and 68 inches tall is closest to, okay? I do not want a percent of students. I want the actual number of students. We're going to get that by finding the percent of students first. Then we'll find out the number. Okay? Anytime, oh, and I love when they use these special magic words, normally distributed. Anytime they give me an interval, like I want to find the percent or number in between this interval, 64 and 68 inches tall, I can use a calculator. I love it. I love it. Don't care. Okay, let me go. Here we go. Ready, ready, ready? In order to do this, follow along, follow along, follow along. Let's clear this out. We need to go to, I said it was normally distributed here in green, right? So above the vars button in blue is distributed or distribution. So I hit second vars, all right? And I'm going to use normal CDF. Just trust me, that's the one you use every time you have an interval, okay? And I'm going to hit enter. And I got this funky little thing here. The lower and upper represent the low end of my interval and the high end of my interval. My interval is from 64 to 68. Okay, so for the low end, 64, and for the upper end, 68. That's my interval. Now you got this little smushed M. I call it a smushed M. Why do I call it a smushed M? Because that M represents the mean. So for that little smushed M, it's 65.5. This little pigtail, that's your standard deviation, 2.9. Okay, 2.9. I'm going to paste this into this little normal CDF command and hit enter. I don't see 50 or 0.503181. I don't see that anywhere because that gave me a percentage of people. That's 50%. Remember, if I slide this over, I would get 50%, right? I said a couple problems ago when we were figuring out that mortgage thing, which was, oh my God, what problem was that? That was problem 9, the one we started with. The calculator doesn't give you percents. It gives you decimals. And that's what I need to use, those decimals, when I calculate things. So it didn't give me the percent. This would have been 50.3%. Instead, the calculator can't do that. It gives you the 0.50 thing that we have right here. That's not an answer. You had 3,300 students. So roughly 50.3% of them are in that interval. So how do I find a percent of a number? I multiply it by the decimal version of the percent. What do I mean? I mean, I take my 3,300 students and I multiply them by this number up here. 1,660 students. 1,660 students, which is choice 1, and that's your answer. 2 more problems, 15 and 16. Let's go. 15. Which statement below about the graph of f of x equals the negative log of x plus 4 plus 2 is true? 3 of these are false. 1 of them is true. Let's graph it, okay? So what I'm going to do, I'm going to clear this out, and I'm going to go right to y equals, and I will do this, I know it's in blue, I'm going to do it in red. Red seems to stand out a little bit better. So I'm going to have the negation of log, which is right here next to the number 7, of x plus 4 plus 2. Okay, and I graph this. Okay, now it looks like it just stops here. It doesn't. And let me explain. This is where x is negative 4. On my table, it looks like if I go up to negative 3, okay, and negative 4 is an error. But what about negative 3.9? What about negative 3.99? What about negative 3? What about if I get closer and closer to 4? Is there an error? Does it just stop? Let me show you something. And you don't have to do this in your calculator. Let's start at negative 4. But let's change instead of by 1 by 0.1, 2, 3, 4, 5, 6. A very small amount. Look, it goes to 9. I don't see that on the graph. 9 is up here. I don't see a point up here. This will keep on getting closer and closer and closer to negative 4. It'll just never touch negative 4, and it will never go further left. It won't go further negative. That's why you don't see any of these things right here, okay? Okay, these all look like negative 4, but really I'm on negative 3.9999. It's just rounding. Here I'm at 4. If I move up, 4.0001, 4.000 whatever 2. So I can get closer and closer to 4. And as I get closer to 4, my y value actually goes up. Okay? So really, what my graph really does, but this is one of those calculator issues that it really can't show it. Let's do this. Ooh, I like my lines. Let's say this green line is x. equals -4. My red line will get closer and closer to it, but it just will never cross it. It'll kind of go up like that. The calculator doesn't show you that, but that's what it does. It shows you on the table. Okay, so let's take a look at this. First one, f of x, the original, has a y-intercept at 2. 2 is right here. It does not cross at 2. It crosses below 2. This isn't it. Okay, the negation of that has an intercept of 0, 2. No, if I negate that, it would flip across the x-axis. It would be a mirror right across the x-axis. So that's not it. Okay, so my red line would reflect over the x-axis to the blue line in order for this one, negative f of x. So let's get rid of that. Get rid of this. Number 3. All right, as x goes to positive infinity this way, x goes to positive infinity this way, all the way to the right. The y goes to positive infinity. It doesn't go up forever. It doesn't go up like this, the graph. It actually comes down like this and gets closer to 0. So it's not this one. By default, it has to be this one. Let me explain. As x approaches -4, as I get closer to this magic line right here, my y, which is goes to positive infinity, goes up forever, and it absolutely does. As it gets closer to 4, it goes higher and higher up. That is 100% true. That is problem 15, and that's your answer. One more. Let's do it. Okay, it's weird to have 2 questions about collecting data that require you to use common sense. I think number 2 on this test, which is in the previous video of problems 1 through 8, it was a kind of same deal where you just had to understand the situation, and this won't take long at all. Number 16 states, a researcher wants to determine if room darkening shades cause people to sleep longer. Which method of data collection is most appropriate? You're not going to do a census. That's just craziness. A survey, you're going to ask people. People could lie. Yeah, or maybe people just don't know. Here's the thing. Do I pick an observational study or controlled experiment? Most people are going to circle this one, which is wrong. But you want to observe someone, if they sleep or not. True. In an observation study, you view someone and you do not get involved. Do not do anything to get involved. Do not, I'm just going to put involved. You can put the word, oh my God, get. Do not get involved. Which means, what if I view 30 people and none of them use room darkening shades? How's that going to help me? If I do watch people sleep, I want to control the experiment. What does that mean? If I have 30 people, maybe half of them will have the room darkening shade. Maybe half of them will not. I'm not even going to tell them, the 15, that's a room darkening shade, or that's the purpose of putting them in the room. 15 of them, I'll put them in a room to sleep with a room darkening shade. And 15, I'll put them in a room that does not have a room darkening shade. You still observe them, but you're controlling their environment. Choice 4, we are done with the second video, problems 9 through 16. I'll catch you outside. We're going to do 17 through 24 and do the last 8 multiple choice questions on the next video. Bye-bye.